the Communications Associate at the Saugeen Ojibway Nation Environment Office. Thank you for tuning in with the 5th installment in our weekly webinar series. Today we have special guests Ryan Lauzon, the Fishery Assessment Biologist for the Chippewas of Nawash, and Kathleen Ryan, the Interim Manager of the Environment Office. So thank you guys for joining us here today.
Pleasure to be here. Thank you.
They're going to be giving us an update on the fisheries. So can we start by you guys kind of describing what your jobs and backgrounds are?
Go ahead, Ryan.
So I started at the Chippewas of Nawash about 11 years ago as the Fisheries Assessment Biologist. Previous to that, I had done a little bit of work with the Department of Fisheries and Oceans, and I also did my Bachelor of Science in Zoology at the University of Guelph. And before that, I was at college and I got my diploma in environmental technology. And I've always been interested in fish, so this is definitely the right position that I'm in.
I just learned some new things about you, Ryan. So I am the acting manager at the Saugeen Environment Office, but before that, I actually am an aquatic ecologist, so studying fish and water. And I did a Bachelor of Science in Environmental Science and Indigenous Environmental Science. And then when I was kind of first introduced to the territory and to Saugeen and Nawash was in 2010 when I was doing my master's, and that's when I first met Ryan as well. And my master's was on larval or baby lake whitefish on the peninsula and looking at nursery habitats. So just what it sounds like, places where baby fish can be safe and grow up and eat lots of food. So I did that research with Saugeen and Nawash. Different times in there, I also worked for the Ministry of Natural Resources as a fisheries technician, and I did a lot of consulting with First Nations about fisheries and environmental assessments. And then I came back to work with the Saugeen Ojibway Nation, and a lot of the work that I really enjoy the most has to do with the territorial waters and fish. And my jam is nearshore fish and wetlands.
And I focus on the commercial fishery with the Saugeen Ojibway Nation.
Okay, awesome. So some questions that we had for you guys was, we were wondering if you can talk a little bit more about the Saugeen fishing rights, particularly around the Jones-Najuan decision.
Yeah, so the Jones-Najuan decision was really what started the assessment program, so to speak. And that decision was a reaffirmation that the Saugeen Ojibway Nation had a right to a commercial fishery and a moderate livelihood. And at that time, there was a lot of, I would say, a lot of disruption in the outside communities. There was a lot of controversy over that decision. So there was a lot of unrest, and there was violence and a lot of racial language and so on, and the reaffirmation of that right. And as responsible stewards of the fishery, the councils decided that it was important to have a fisheries assessment program to keep track of what was going on with the fishery and make sure that we have a sustainable fishery so that there's fish for generations to come.
And I think another important thing about that, and Ryan sort of, as you said, it reaffirmed the right in that court case by the success of that court case. But I think for the Saugeen Ojibway Nation, that was always there, and it was just that it was recognized in court so that Canada and Ontario and others would actually uphold that, right?
That's right.
Yeah.
And so before the Jones-Najuan decision, the government had essentially legislated Saugeen Ojibway Nation out of the water. So they were basically left with a little postage stamp around each community that was open to commercial fishing. And according to the law, however, it wasn't accepted by the Saugeen Ojibway Nation. And so there was a man by the name of Francis Nawash who was charged and brought to court, and the chief at that time, Howard, was also brought to court, and that's where it was, they decided that enough was enough at that point, and council got involved, and we ended up winning the case, and we are where we are today with that reaffirmation, and the Saugeen Ojibway Nation continues to fish commercially now.
Okay, that's great. Well, that kind of leads into, that's a good overview of the history. So that kind of leads into, well, what does your program do now then?
Yeah, so I run the Chippewas of Nawash Fisheries Assessment Program. I have a counterpart, Harold Thompson, who is running the Saugeen Fisheries Assessment Program as well. And together we are essentially there to monitor how much fish is being harvested by the commercial fishermen in the territory. And also we take samples to see, get information about individual fish. So when we go to the dock and we meet with the fishermen, we take samples from those fish that they caught, and we measure them for things like the total length, the fork length, which is basically where the fork comes in. You take a measurement of that. We take weights. We take some structures from the fish, like the scales and the otolith, which is the ear bone in the fish. And we use those, so we actually age those fish with those structures. If you cut an otolith into sections, it actually has rings on it. Much if you imagine how you age a tree, you can count the rings and figure out how old that fish is. Same thing with a fish scale. If you take a fish scale and put it under the microscope, you'll see there's rings on there. And for lake whitefish, you can use those to figure out how old that fish is. And otoliths and scales, scales are good for fish that are younger. They're quick and easy to do, whereas an otolith is more time consuming, but it lays down finer detail. So you could actually age older fish where the rings are getting closer and closer together. You can't necessarily see that in a scale, but with an otolith, you could actually see that pattern that was laid down and age it to those older ages that we're now seeing in the water.
I was going to say, maybe you could touch a little bit on why aging fish. So why figuring out the ages and total lengths and fork lengths of fish is important in figuring out how healthy the fishery is.
Yeah, absolutely. And it's more of a concern now than it has been ever in recent times, because we're actually seeing a decline in lake whitefish abundance. So some of the models that we use to try and figure out what's happening with fish are based on what they call an age structured model. So it takes into account how old the fish are to try and figure out the health of the population. And also it's very important to know what they call age classes. So each year is a separate age class of fish. And it's very important that a fishery has a wide, diverse range of age classes. And the reason for that is that that means that there's recruitment or new fish coming into the population each year. We're not necessarily seeing that with whitefish right now. We're seeing a lot of the fish getting older and older and larger and larger. And we know this, for one, by seeing how heavy the fish are getting and the lengths and so on, but also by actually aging them and figuring out how old they are, because fish don't necessarily, their size isn't necessarily reflective of their age, because with a fish, depending on how much they're eating, it will greatly influence their growth. So it doesn't necessarily directly correlate to age. It's a lot to do with how much food is available, how big a fish is going to get, and how quickly it's going to grow.
Okay, great. Well, I guess that kind of leads into our next question, which is, can you tell us a little bit more about the current health of the lake and the state of the ecosystem there and the fish in relation to that?
Yeah. I was going to say, before doing that, I was just thinking it might be helpful to just do like a brief of what is a life cycle of a fish. Like if we're talking about recruitment and if we're going to talk about the health of the lake and the fish, it's probably helpful before we talk about that to say these are the different life stages of a fish, because we know that some are more or less affected by what's happening in the lake right now, right? So I could just do a quick overview, and I'll use lake whitefish as an example.
Sure.
So we could say probably that lake whitefish have 4 maybe distinct life stages, and they use all different parts of the lake for those different life stages. So of course there's adult fish, these larger fish, and usually adults are characterized by fish who are able to spawn. They're able to spawn, they're able to reproduce. So adult whitefish usually live in the colder, deeper waters of the lake for a majority of the time, and will come closer to shore to feed right before spawning time. And then they'll spawn on the shoals that are closer to the shorelines of the lake, not really close, but closer than the deep cold water. And some are very close.
Some are very shallow for sure.
Some are very shallow, like in Stokes
deep.
Bay. Stokes Bay has really shallow shoals. But anyway, those adult fish will come and they'll lay their eggs. So then the egg, the fertilized egg, is another life stage. And then those eggs incubate over the winter, and then they'll hatch in the spring. Again, off these shoals. And then you have your larval fish. And the larval fish, and I won't ramble on about this, but I could, because those are my favorite fish. The larval fish then hatch and are at the mercy of the water, of the currents, of the waves, and they basically go where the currents take them. So currents and waves and water temperature are extremely important when those fish hatch. Ideally, those very tiny larval fish get pushed into the embayments on the peninsula, if we're talking about the peninsula right now. And then in those embayments, ideally, there's a lot of productivity because it's shallower, it's a little bit warmer. There's usually nutrients coming out of rivers and creeks into those shallow areas. And that means there's more tiny little food particles to fit in the larval fish's tiny little mouths. Then those larval fish grow and feed there, and then they'll grow into late stage larval fish, and they'll start to progress towards being juveniles, where they start to try to find the thermocline. So where the lake sort of separates into that deeper, colder water. And then it still takes them a couple years before they're what the word Ryan used, recruitment. So before they're considered part of the fishery. So before their recruitment age is 2, is it?
No, it's probably 4 or 5 in there.
So they take a couple years before they're even part of that fishery. And so we'll talk about this in more detail, but I think what we're seeing right now is that older part of the lake whitefish population, based on fishing, is there. But these younger ages in the population, these smaller or younger age classes, are starting to not be there.
That's right.
That's right.
Yeah.
Yeah.
So then, like, just in terms of that, like, what could be causing that lack of those younger ages being abundant in the lake?
There's a lot of theories right now.
There's many hypotheses.
Yeah, there's a lot of hypotheses, but nobody fully understands at this point what the reason is behind the decline in lake whitefish populations and why fish aren't being recruited. It could be invasive species. So the quagga mussels, which were introduced through ballast water introductions, and basically they've taken off, and it's believed that they're essentially filtering the water out of all the small food particles that Kat just spoke about, so that there's no food when those larval whitefish hatch and they go to feed, that there's not enough food available. So that's one of the hypotheses. If you talk to fishermen and they will tell you that there's seeing a lot of the lake trout that have been reintroduced by the Ministry of Natural Resources and Forestry, that they're finding a lot of really big lake trout and they have whitefish inside their stomachs. So they're concerned that perhaps these lake trout are feeding on lake whitefish.
Which is a new thing.
Which is a new thing.
This is not something, lake trout were historically part of the lake food web, and it seems to be a new thing to find the size of whitefish in the stomachs of lake trout that are being found, right?
Yeah, so
this is a new dynamic.
That's right. So lake trout were here originally. They were largely wiped out except for a couple populations, for example, in Parry Sound. And the ministry has been stocking lake trout in efforts to what they call rehabilitate lake trout. And so now we're starting to see quite a few lake trout out in the lake, including some real big ones. And what we're hearing from the fishermen is that they're these now quite large lake trout, they're finding a lot of lake whitefish in their stomachs, and also they're concerned that they're seeing them in places lake trout in places they hadn't seen them before, and they believe that they're actually driving the whitefish out of areas where whitefish used to be. Now they can only find lake trout. So that's something that is also a hypothesis that maybe behind the decline. Is certainly something that we're interested in exploring more. In addition, we all have heard all about climate change, and we know that climate change is real and it's happening, and the fishermen are seeing signs of climate change, and it may be having an impact too. We just don't know. There's lots of other hypotheses as well. It could be the changing water levels in the lake. We've seen that the lake levels now are very high. In fact, I believe they might even be at historic highs. So those changing lake levels affect the spawning shoals and the habitat and all those areas. Also, it's believed that ice cover over the winter and how the ice cover interacts with the spawning shoals is an important factor. For example, if there's a layer of ice, but it's not too thick that it freezes the shoals up, which I've heard can happen, it acts as a protective layer to prevent wave action and so on from scouring the shoals and washing the eggs out and that type of thing. And so there's so many factors at play, and we're trying to understand better what exactly is going on. So it's a big question mark still, but we're doing our best. And by we, I mean around the lake, there's researchers that are out there trying to figure out what's going on.
I think water temperature, like if you talk about climate change, water temperature, I'm always fascinated by water temperature, because temperature is, I would say, one of the most important factors for fish. And I talked about all those life stages, in all of their life stages, because for fish, water is their air, right? Mm-hmm. And that dictates and signals them to do almost every biological thing that they do. Water temperature is how you will know when fish are going to spawn, because water temperature is what signals their internal bodies to start doing things. And that's why, for example, there was research in the past, in the 70s and 80s around Bruce Power, where fish, say a sucker, was found in the discharge channel at Bruce Power, which of course the water is significantly warmer. Suckers do not spawn in February, and suckers were found in there fully ripe and ready to spawn. And that's because the water temperature was telling all of their biological parts to start getting ready to spawn. And then the ice cover, which is part of water temperature, when those fish do lay their eggs, that water temperature that they're incubating in makes a really big difference. If the water is, already ice cover is one thing. The ice cover helps to incubate them, helps so they're not knocked off the shoals. helps to keep them. The shoals have nice little pockets.
Honeycomb, they call it.
The honeycomb, and it perfectly fits the eggs. It's very nice. And then how long they stay there depends on the water temperature. And if, say, there's a sudden, say in the middle of the winter in March, I remember this happened when I was doing my research in Stokes Bay, the water temperature spiked for like a week. And that water temperature could signal those whitefish to hatch. And the whitefish, those baby whitefish, might not be fully developed because they haven't developed for long enough, or their mouth size, which is the last thing to fully develop, might not be big enough to actually fit food in their mouths. Or if they hatch too early and the rest of the lake is not ready, and like the rivers haven't begun to thaw and there's not all this productivity happening, then there might just be no food for them to eat. And the same thing is true even if those fish hatch at a good time, at a regular time, sort of April-ish. The same thing is true, that if the water temperature is changing too much, they won't survive these changes in heat. And the same cycle just continues, and that's just not for I'm using whitefish, but that's for all fish. That signals all fish and their biological movements, and all fish lay eggs, and how their eggs incubate and how their eggs hatch. It's very important.
Yeah, absolutely. And I totally agree that the incubation period for lake whitefish can be vastly altered depending on the temperature. It could be extended. It could also be vastly reduced, and that all has implications.
Well, it's the same thing like with a baby, right? If a baby is only, if your gestational period is shorter than 9 months, then sometimes there's developmental problems with the baby. It's the same thing with a baby fish. If the period is shortened too much, then their fins might not be good enough. They're not really able to use them anyway, but their fins might not be good. Their mouth, that's the biggest thing actually with fish who haven't incubated long enough. Their mouth is not big enough to fit tiny little bits of food, and then they just die. And I mean, many, 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 many eggs are laid, and the survival of the larval fish is low anyway. So the last thing any fish needs is additional things that would cause their survival to decrease, right? So I think there's that part of what's going on in the lake, like with lake whitefish, a few different things that could be going on. But I think the lake is actually, from my perspective, the lake is undergoing a big change as a whole. The food web is sort of shifting. The temperature is shifting. We know the water level. I know water levels do fluctuate over time. There's a good record of water levels fluctuating, but we can't predict actually if the water level will drop right back down again or what will happen. But there's a lot of different things happening in the lake, and we're seeing that not only with lake whitefish, but with other species and the way they're behaving and moving around the lake.
Many, many changes going on. Absolutely. We're losing that, the plankton, so those lower trophic levels are being vastly altered, which is affecting everything above them.
Yeah. So we said the lower trophic levels, those nerdy words.
Yeah.
But that's right. Like Ryan talked about earlier, that there's an idea that's probably fairly accurate that these maybe combinations of invasive species, like the round gobies, who are really effective, they're crazy effective at reproducing and at feeding. At
feeding on fish eggs.
And feeding on fish eggs.
Yes.
And quagga mussels are very effective at filtering. And not only is that causing fish eggs, so reproduction, to be lost, plankton, these maybe like phytoplankton, the very small planktons, which are really important food, to be lost. But you can talk more about this, I know, but it's also causing, when people look in the lake and they're like, wow, the lake is so beautiful and clear. Clarity is not always a good thing. Like Lake Huron and Georgian Bay are relatively clear, but because of the filtering, light is able to penetrate deeper into the lake or in different places into the lake, and that's causing more problematic algae growth.
Yes,
And that's causing problems for the fishery
absolutely,
and potentially for the spawning shoals as well.
absolutely.
Because spawning shoals might have some vegetative growth on them, but they're rock, right? But now algae is forming on them, which might cause problems when fish are or not really when the fish are spawning, but when the eggs are being laid. But we don't know, I don't know fully about what's going on in a whitefish's brain, but that might not be the right sort of place for them to lay their eggs. They can sense whether they're in the right place to lay their eggs. But maybe you can talk about the algae problem, what that's creating.
Yeah, so we hear from the fishermen quite often about their concerns about algae because, as Kat said, with the increase in water clarity, that means that the light is penetrating far deeper into the water column than it did in the past. So we're seeing algae moving deeper and deeper into the lake. And it's essentially on the bottom, and it's got a perfect environment there because not only are the quagga mussels filtering the water, so they're increasing the clarity, allowing the light to penetrate deeper, but they're also depositing their waste on the bottom, which are nutrients for those algae to grow. So it's kind of, the quagga mussels are doing a nice job of feeding the algae and allowing more light for the algae to grow. And fishermen end up, especially when there's a storm and all that algae is getting swirled around, and it ends up coating a fisherman's net, and it can wipe out the net completely so that when they retrieve it, it's no longer usable, or it's very difficult to clean that algae off. So it makes fishing a lot more difficult than it was in the past. And certainly the fishermen experience that, and they're trying to figure out ways to clean their nets better and all the rest of it, but it remains a very hard challenge.
And not all algae is bad.
No.
That algae is not good. But not all algae is bad, but actually algae can be, if there's too much algae, it can be very toxic to aquatic environments, even in the near shore areas, and it can cause basically the oxygen to just be sucked out of the water, and fish need a certain amount of oxygen content. Like I said, it's their air to live. So even in near shore areas where that's becoming a problem, where there's all this algae growth, that can be really bad for fish habitat. And all water is fish habitat.
Yeah, absolutely. If the algae dies and it's decomposing, then it's sucking, as the decomposers break it down, they're sucking all the oxygen out of the water, and certainly that can be an issue.
Mm-hmm. So I think there's also, I'm trying to think of all that, there's so many complex things actually happening in the lake, but I think Ryan and I actually think a lot about this. So there's these sort of biological things that are happening. We're really talking about lake whitefish because we probably focus a lot on lake whitefish, and we know a lot about lake whitefish because it's really important. But there's, things happening biologically that relate to invasive species. There's things happening with a reintroduced predator, the lake trout, which we might do another segment on all by itself because that's a really important issue right now. There's other things happen with other introduced predators like salmonids that are in the lake, which also are probably competing with the other top predator now, the lake trout. There's a bunch of biological things happening, but then there's also around the territory, even if you just, the territory, there's also other things happening on the shoreline that are causing really big changes to the aquatic environment. And these things are happening relatively rapidly in historical timelines. This is a rapid change. So shoreline development, shoreline alteration is a major issue in the territory. This is, whether it's, cottages being built. If you're building a cottage, if you're doing something right on the edge of the lake, there's going to be runoff, there's going to be disturbance, there's going to be all sorts of things. Most people who develop right beside a lake, though, they build a dock. Docks have impacts to the fish habitat, depending on the type and size of your dock. It can also have big impacts on water currents and movement of water, which is again very important for larval fish for one. But it can actually in a bay, say like Stokes Bay or even like Oliphant in the fishing islands, there's not tons in there, but it could change the way the water moves through those areas. And again, this is like a pattern that fish are I would say like programmed to, right? This certain pattern of water. So it's like the death by 1,000 cuts, right? There's lots of other things. There's other things related to contaminants, more historic contaminants, but also ongoing impacts of industrial development in the territory. Some of the bigger one, that's the longest standing one, is probably Bruce Power, right? A lot of people are concerned about Bruce Power, radiological, thermal, so the heated water that goes into the lake and the impingement and entrainment, just the sucking in of fish into the plant as part of the cooling system to cool the reactors down. And that's like a focal one because it's big, people know about it, it's there. But there's also tons of smaller things, but when you add them all up, they can be relatively
The cumulative impact.
cumulative impacts.
Yes. And even going back to mussels, even the concerns about whether the mussels are, we don't know what's going on in those spawning shoals. And it's probably something that we should be taking a bigger look at because those mussels are colonizing a lot of the waters. So we don't know if they're having an impact on the shoals themselves and the fish's ability to spawn on those shoals. And it's not all bad news. There's some fish that we're seeing more of that we have seen in the past. Right now, there's a lot of walleye or pickerel being produced, for example, in particular in Saginaw Bay, and they're actually migrating out there. We're seeing much bigger harvests in the Saugeen commercial fishery from those walleye and pickerel. Even some of the fish like perch were starting to come back to some degree. We're starting to see some higher harvests of perch, fish like bass and so on. So it's not all bad news, but there's certainly a lot of changes going on and a lot of the effects have been unfortunately
there is
negative.
a big shift.
A big shift.
A big shift, and you know, we don't know that much about it, but fish like walleye or pickerel and more yellow perch, these are again fish that we start talking about water temperature, fish that are generally more productive in areas where there's not as cool water temperatures as there are in the main basin of Lake Huron. So some people are thinking that's a signal of broader sort of slow but temperature change that's happening. And I think pickerel, there's some other reasons, like alewives used to eat tons of pickerel eggs, and the alewife population has decreased substantially. But
yes.
Alewives are egg eaters and would specifically, because of where walleye lay their eggs, would just eat all the walleye eggs, right? And then there's, I'm going to plug my program now. So then there's the Coastal Waters Monitoring Program. So that's being run out of the Environment Office, and that we started this year. And it's really meant to be complementary to the work that the Fisheries Assessment Program is doing, because the Fisheries Assessment Program is really focusing on a lot of the commercial fish species, and in some other areas of the lake that the Coastal Waters Monitoring Program we would never have information on. For example, the Coastal Waters Monitoring Program, the gear that we use, the locations that we sample, we would never catch an adult whitefish. No. That would never happen. But where we're sampling are areas that are important for those, again, younger life stages of lake whitefish. So those larval fish, eggs, maybe early juveniles. We'll still use those areas, but they're also really important for tons of other fish. Those nearshore areas are They're crazy important because of how productive they are and how many species come there at some point again during their life history to do something. So at some times of year in, say, the fishing islands, we'll catch hundreds of perch. I've caught hundreds of perch using live trap nets in there, hundreds. And there you'll see all different age classes. So you'll have yearlings from that year. You'll have ones that are clearly about a year old, and then you'll have big, fat, meal-worthy perch.
Adult, mature perch.
Okay, mature. You have those size of perch. But what other things that we catch there are also indicative of the types of smaller fish that are available for food. So cyprinids or minnows and shiners. And there's many, many, many species of minnows and shiners. A lot of people think there's just minnows and shiners, but there's many species and they all have really distinct purposes and are food for certain species. So the diversity of species is really important. And some of them stay at the bottom. You have this importance of also things that fulfill different places in the water column. Things that stay at the bottom, things that are in the middle, things that are closer to the surface. And when we start losing diversity, that's when some of these bigger shifts in the food web start happening. Because everything's connected, right? Once one thing starts to shift, everybody starts to shift. So in the coastal waters monitoring program, this year, we just started to build that baseline. So that base core of information that you can then measure against. So nobody in the territory, not M&R, that's really all there is. Not M&R, not the conservation authorities, not any private groups. Nobody has a comprehensive baseline of the entire peninsula, let alone the territory. And so we really wanted to start that this year so we can measure. So we did live fish nets at 23 locations. We caught 64 different species of fish and I think a total of 76,000 fish. That's a lot of
fish.
Yeah. And 64 species is really significant also. And we haven't analyzed any of that. We will analyze it and we'll have a report that will go out to the communities so you can learn what we've learned this year. But the most important thing is that then next year we'll do the same thing, or maybe add some sites, we'll do a similar thing and we'll keep doing it and keep doing it. And that's how you can measure change or identify, once you analyze your data, you might see, I'm just going to use it as an example, but like what's going on in Colpoys Bay or what's going on in Bay de Dore near Bruce Power. There's something different in these two places than everywhere else. And then you can start to dig into why might that be? And you can start to, if there is something that somehow you can get involved in to change, if it's a shoreline development, if it's an industrial reason, then you have something to base that on and to know what that's about. And we're also collecting temperature data from all over the lake in these more nearshore areas. But that's again going to be really important. So do we suddenly see much fewer or much more fish in certain areas that have certain temperature signatures? And then we can, or species, certain types of species. Like it's all going to be very
There's a lot of learning to do.
There's a lot of, that's why originally, I first got really into fish and water ecology is because, and now it's really frustrating. No, I still believe this. The reason why I initially got into aquatic ecology was because I thought how awesome and mysterious are fish. We can't see them 90% of the time. We can make a lot of guesses on what we think they're doing or where they're going. And mind you, there's advances in technology now. We can put radio trackers in fish and kind of figure out where they're going, but I still don't think we really know because there's hundreds of thousands, if not, millions of fish in the lake that might be doing slightly different things if there's smaller families or populations of fish, communities of fish that might do things differently. But that's why I originally got into fish was because I thought how cool, how interesting. We don't really know anything about these things, right? We don't, and still now, how many questions have we raised of, it might be this, or might be this, might be this other thing, could be this.
And here I am, I got into fish because I like to go out fishing and catch them on a rod and reel.
I have never caught a fish on a rod and reel. I like to look at baby fish, and I think fish are, when I started studying larval fish, that's why I thought they were so, that was like a really, really cool learning moment for me. Like, I did a lot of nearshore fish assessments before I did my master's, turtles, the same kind of stuff the Coastal Waters Monitoring Program does. A lot of cyprinids, minnows, shiners, suckers, chubs, bowfins, all that kind of stuff, which I thought was great. But then when I started doing larval fish, I was like, oh, they're the most mysterious of them all, right? And they are, because we still don't know very much about larval fish. And that's a really important part of all fish's life stages, right?
Absolutely. I think there's so much to learn about fish in general, and even whitefish. We don't have a full understanding of their movements, and there's still, I guess, contradictions between SON's traditional or ecological knowledge about fish movements versus what is published in some of the literature and what we hear, for example, from the Ministry of Natural Resources and Forestry. So I think there's still many questions to be answered, and many questions I'm sure yet to be asked.
And I think what you said about, SON community members' traditional ecological knowledge, I think that's so important because, and I will say this too, I went to school for aquatic ecology, I did a master's or whatever, but the most that I've learned about anything to do with water and fish or turtles or larval fish is from physically being there and doing the thing on a repetitive basis and observing and thinking about it. And that is traditional ecological knowledge, is the practice of doing and being there and connecting with whatever the thing is, right? A person who has a crazy amount of knowledge about whitefish has fished or been around fishermen, and that's been part of their life, not reading about it, but experiencing it, right? And I think we do have lots of disagreements with not just the ministry, but lots, just totally different worldviews.
Yes.
Right? And this one is, well, we proved this with science. And I went to school and got a science degree, but I don't believe some of the ways of proving things. Whereas over here, I experienced and observed this for an extremely long period of time, and also learned all this stuff from my uncle or grandfather or father or whoever. And now I have this crazy body of knowledge that helps me to understand what might be going on right now. Right? I think it's
really important to understand, or to for others to understand that both perspectives have strong value.
Yes.
And in the past, I think that Indigenous knowledge did not have much value placed on it. And I'm not going to say that that has necessarily changed, but I think it's starting to change slowly. But we still have a long ways to go. And I think as scientists, we have to recognize that and understand that through science, we can learn a lot about various things, but science tends to focus a lot on, reductionist methods and looking at a small little piece of the puzzle, whereas the Indigenous knowledge system tends to be more of a holistic approach that looks at the system as a whole. So I think, these two systems of knowledge can both help explain what's going on with whatever question you might want to ask. And it's important not to get too focused on one particular perspective, or you're going to be missing out on something that's really important over here.
Yeah. That's like, even, I was just thinking about a certain species of fish, but even some names for fish in the language in Anishinaabemowin can actually help you understand more about that fish,
Absolutely.
right? The names of some fish are like, then you're like, oh, so that's what's important about that fish, right? Or like that is a key thing about that fish, and I didn't even know that until I knew that name for that fish.
Yes.
Or locations in the territory. When you learn the original name of that location, you're like, oh, that place must have been really important for sturgeon at one, you know, and then you actually start to learn more. And if you know a place name, say there's places like there's several places with sturgeon names in them. And then you think, well, there's not sturgeon there now, right?
Yes.
Then you think, okay, something seriously changed over time, right? And that's also that longer knowledge of how has this whole system been changing over a long time scale, right?
Absolutely. Even if you look at the name for whitefish in the language, from what I've been told, the Tigamig means caribou of the sea, and it doesn't literally mean that, but I've been told that it refers to the noise that caribou make as they go on their migration, and that's where they got the name from, because it was widely understood that lake whitefish made large migrations throughout the waters, and that's still the understanding that the fishermen have to this day. That's when you ask them about whitefish, that's what they'll most likely tell you about them.
Mm-hmm. We could talk about this for days, Karina.
Oh, yeah. Well, it's really interesting. That was it for my questions that I had for you guys about it, but we're hoping to have you guys back again in a future week to talk more about the fish stocking and the lake trout. Well, thank you guys very much for sharing all of your knowledge and for participating in our webinar. If we get any questions from the audience after the fact, we'll forward them to you guys and then post them on our website and social media. But thank you to everybody that tuned in, and hope you have a good evening.
Thanks, everybody.
I had to do it again.